Alright, ladies and gentlemen, welcome to the notes for Chapter 4, Section 1 in your pre-calculus textbook. This is also the first official lesson of our trigonometry semester. This lesson is going to cover right triangle trigonometry, SOHCAHTOA, specifically sine, cosine, and tangent, and will serve as a review of what all of you should already know about trigonometry coming into this course. So, in geometry, we spend a significant amount of time, several chapters in fact, studying right triangles, and more specifically, we even go into trigonometry. So when we're given a right triangle, we always have several things that we are able to use to find missing side lengths, to find missing angle measures. First of all, there's the Pythagorean theorem, which says, a squared plus b squared equals c squared. Again, where c is the length of the hypotenuse, or the longest of the three sides. We've got special right triangles. You've got your 30, 60, 90 triangle and your 45, 45, 90 triangle. Now in geometry, these are not horribly emphasized, although they probably could be, because special right triangles, any triangle that contains a 30, 60, and 45 degree angle would be similar to any other triangle with 30, 45, and 60 degree angles. 30, 60, and 90 degree angles. So then we can set up and solve proportions using those special right triangles. And also SOHCAHTOA, that is stating that the sine of whatever our angle is opposite over hypotenuse, which is SOH or SO. Cosine of our angle is adjacent over hypotenuse, CAH or CA, and tangent of our angle is opposite over adjacent, which we should remember TOA or TOA. That's where SOHCAHTOA comes from. Remember that sine, cosine, and tangent are specific trigonometric functions that describe a specific relationship between two of the three sides of a right triangle. Again, it all depends on what angle we are working with. So we're going to review that first. So we're going to be focused in this lesson on that third one, SOHCAHTOA, and we are going to be reviewing that information. So, in any right triangle, the sine, cosine, and tangent of an angle is defined as, and we're going to use angle A in this case here, so this is angle A. When we look at this triangle, angle B is a right angle, which means that side AC is the hypotenuse. It is the longest side of the right triangle, so it is the hypotenuse. Now, in addition to that, the other two sides of the triangle have names as well. Side BA is the adjacent side to angle A, and BC is the opposite side to angle A. Because if I go opposite of angle A, I find that side. If I go next to angle A, I find the adjacent side. Okay? A couple things to note before I define sine, cosine, and tangent. Number one, the hypotenuse is always the hypotenuse. It doesn't matter which angle we're working with, the hypotenuse is still the longest side. It is always opposite the right angle. Adjacent means next to, but not the hypotenuse. Okay, if you look at angle A, there are two sides next to angle A. One of them's the hypotenuse, the other one is always the adjacent side. And opposite means across from the angle. Again, it's not the hypotenuse. So the key is always name the hypotenuse first. This will allow you to identify the other two sides with relative ease. Now, the sine of angle A is opposite over hypotenuse. In this case, that would be side BC over side AC. The length of BC over the length of AC. The cosine of angle A is adjacent over hypotenuse. In that case, that would be AB over AC. And the tangent of angle A is opposite over adjacent. which would be BC over AB. SOHCAHTOA. And all of that should not be new information. We should know all of that coming in from our geometry course, which may have been 2 years ago. Okay, so here is a triangle. We're going to find in this triangle the sine of angle A, the cosine of angle B, and the tangent of angle B. So the first thing we need to do is name the sides. So we have to think to ourselves, okay, angle C is our right angle. So which side would be the hypotenuse? Well, if we go opposite the right angle, we find the longest side. So the 13 is our hypotenuse. Every single time. Doesn't matter which angle we're working with, A or B, we are always going to use 13 for our hypotenuse. And then the other two sides, well, it all depends on which angle we're working with. If we're working with angle A, then angle 5 is the adjacent side for angle A, and the 12 is the opposite side for angle A. However, if we turn our attention from angle A to angle B, well, in that case, 5 would be the opposite side for angle B, and 12 would be the adjacent side for angle B. So it's a matter of noticing that there is a difference when we're going to do these problems. So we're asked to find the sine of angle A. Notice that I've done all the naming up here for angle A in red. So the sine of angle A is going to be sine is opposite over hypotenuse. But the tricky part is that we have to use the side that is opposite of angle A. So in this case, that would be 12 over 13. The cosine of angle B, notice that I'm writing B in blue because that's how I labeled the triangle up here. Blue are the labels are for B. Cosine is always adjacent over hypotenuse. And since we're working with angle B, we are going to use the side that is adjacent to angle B for adjacent. So that is also the 12. I'm sorry, adjacent to angle B would be the 12, yep. And the hypotenuse would be 13. So notice that the sine of A and the cosine of B are the same value. That's fairly common information, and it does come up quite often. Finally, we have the tangent of angle B. Again, the labels we use, it all depends on the angle itself. So the tangent of angle B would be tangent is opposite over adjacent, and we would be using the blue labels because we're dealing with angle B, which is the angle I've marked with blue. So the tangent of angle B would be opposite over adjacent, which would be 5 over 12. Okay, so going on further than this, we can actually use trigonometry to solve any right triangle. We can find any missing side, any missing angle, if we know that the triangle is in fact a right triangle, if we know one of the angles and one of the sides, or if we know two of the sides, that would work as well. So the way that that works is that we need to go in and we need to pick an angle to work with, because we need everything named based on that angle. Now then, based on that angle, we need to pick our trig function. Okay, again, we're going to be using SOHCAHTOA for this. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Now, with the information that we have available to us, we need to decide whether we are dealing with a sine, a cosine, or a tangent problem. And all of that is going to be based on which two sides we're working with, based on the angle that we chose. We'll set up the problem using SOHCAHTOA, and then we will solve the equation for the variable. Okay? So first of all, notice the directions here. They do state that all of these triangles are right triangles. This is important because SOHCAHTOA only applies to right triangles. It does not apply to obtuse or acute triangles, only right triangles. Okay, so example 2 asks us to solve for W. So what I'm going to point out here is that we do in fact have one angle. So there's not really a choice. We're going to use the 54-degree angle because that's the angle that we have available to us. Now what we're going to do is we're going to look at the problem and we're going to go, okay, here's the right angle, which means the two sides that I know are the opposite side to the 54-degree angle, which is W, is what we're trying to find, and we know the adjacent side. So, since we know opposite and adjacent, or since we're working with opposite and adjacent, that means that this problem is a tangent problem, because in SOHCAHTOA, sine is opposite over hypotenuse. We don't know anything about the hypotenuse. Cosine is adjacent over hypotenuse. Same problem. We don't know anything about the hypotenuse. But tangent is opposite over adjacent, and we have something to put in both of those spots. So this is a tangent problem in example 2. So we're going to write out our equation. Our equation is always tangent of the angle, 54 degrees, equals opposite over adjacent, which would be W over 10. Then to solve that equation, we need to get rid of the fraction, which requires us to multiply both sides by 10. When we multiply both sides by 10, we get that W equals 10 times the tangent of 54 degrees, and we're going to put that into our calculator. So you'll notice on your calculator, and every scientific calculator, even the ones embedded in smartphones, have a sine, cosine, and tangent button. So you guys are dealing with TI-84 Plus graphing calculators. The sine, cosine, and tangent button are located directly above the numeric pad, 2 lines above. Sine is first, then cosine, then tangent. See the buttons right there with the names on them. So you're going to type it in exactly like it reads. 10, then hit the tangent button, and type in 54. When we do that, you should get 13.76. And I'm only looking at the 6 because that is how I round. Now, if you did not get that answer, your calculator is probably not set to degrees. So what you need to do to fix that problem is hit the mode button on the very top line of your keypad and make sure that degree, D-E-G, is highlighted. When you've got 2 choices, radian and degree, make sure your calculator is set to degrees. Anyway, 13.76, that 6 tells us to round the 7 up, meaning our final answer would be W is approximately 13.8 units. It is a side length, so it's 13.8 units. Okay, so then example 3 asks us to find the hypotenuse. So we'll throw another variable in there. Let's say that we use x instead, which would be our hypotenuse. Now we are not going to be using opposite anymore because we don't care about W. Instead, we're going to be working with adjacent and hypotenuse. So when we go to figure out, okay, if we're working with adjacent and hypotenuse, which trig function should I be using? Well, adjacent and hypotenuse are related to each other through the cosine function. So again, we'd write out the equation. Cosine of 54 degrees equals 10 over x, adjacent over hypotenuse. Now the x is not on the top of the fraction this time, it's on the bottom, which means it's going to take a little bit more work to solve. We start by multiplying each side by x, that will eliminate the fraction, and change the equation into x times the cosine of 54 degrees equals 10, and then we will divide by the cosine of 54 degrees. We do this because that will get x by itself, which anytime we're solving an equation for a variable, that's what we're trying to do, is get the variable by itself. So that gives us that x, the length of the hypotenuse, is 10 divided by the cosine of 54 degrees, and we're going to feed that to our calculator. So we're going to hit 10 divided by the cosine button, and then type in 54 and close the parentheses. We should get 17.01, which would tell us to round our answer down to 17.0 units. Okay, so we're going to end our first video here. There are still more notes to this section, so this will continue in following videos. But this is what we do here to find missing side lengths. We set up and solve an equation based on SOHCAHTOA. Thank you for your time. If you need a different part of the notes, go to the next video and watch more. Thank you for your time.